In this video, we'll wrap up our discussion of the first section of DiffyQ, focused around verifying solutions of DiffyQs. This is where it starts to kind of look crazy, but it's really just two problems in one in a way. So this kind of explains why that last problem, we had an x of t, is when you guys get to Calc 3, or if you've taken already, remember we start learning how to express things in terms of a parametric equation rather than just an x and a y function, because it allows me to have things that do this on an xy plane while I can't express that with a yx and keep it a function. It also will take something like this and allow us to think about it as a path described with time, after 5 seconds, after 10 seconds, stuff like that. All right, so the thing is with this, verifying it, they have these two equations, and then this is your setup. All you have to do is I just find this derivative and try to match it to that and see if I can just get them to work out. So left-hand side, let's do the first, let's actually find our derivatives first. So I have the x is e to the negative 2t. If you're not comfortable with this e stuff, this is a lot of diffie. It's just the natural world works with ease. So x prime, right? We get the same thing, but the chain rule produces a -2. And then same thing here, but I'm gonna get an 18 because I multiply those two, keep my 6t. So there's x prime. So let's go ahead and just verify the first one. So left-hand side, I'm gonna do dx dt. Um, is equal to, oh, we just had that. Okay, so -2, I'm just going to write it again here since I already wrote it, just to be neat. 6t, okay, and then the right-hand side, to verify it, is going to be x plus 3y. Okay, well, that's going to be e to the -2t, right small here, 3e to the 6t plus 3 times, and then times y, 5e to the 6t. And all I got to do is verify that that is also the left-hand side. So if I add those together, or multiply first, I guess let's do that. Remember, when I'm verifying things, I want to show steps. That's what verifying is show the baby steps to get to it. Verify it. When you skip too many steps, then there's what's the point? Okay, so now I can only add like terms, and the like terms are the e's with a certain exponent. So let's add, I get -2 e to the -2t, and then 3 and 15 make 18 e to the 6t, which is exactly what we got up there. Okay, so now we have to do, we did the x dx dt, let's do dy dt. So y here is going to be -e to the -2t plus 5 e to the 6t. Now, usually I would do that y prime right there, but we found out last time that we're just going to have to do it right here as well. So dy dt is equal to, okay, the -2 is going to come down, with that negative making a +2 e to the -2t. And then the 6 comes down making a 30 e to the 6t. So that's what the derivative on the left-hand side is. Now let's do the right-hand side. So the right-hand side was 5x plus 3y. So we're just plugging each one of those in. X is e to the -2t plus 3e to the 6t, plus 3 times y now, -e to the -2t plus 5e to the 6t. And then all I got to do is multiply that out to make sure it works and add like terms. So let's do that. So we get, oh, forgive me, we get 5e to the -2t plus 15e to the 6t minus 3e to the -2t plus 15e to the 6t. And then I'd add like terms. Okay, so -2, I get 2e to the -2t. 15 plus 15 makes a 30e to the 6t. And that's what we got here. So we're good. So we verified it. You sometimes will ask for the interval. In this case, if I'm looking at x and y in here, I can pick any t I want, and I can take e to that power. Okay, I want to do one more here, and this one's kind of silly. But people tend to see this kind of crazy theory type problems and they kind of start stressing about it. Um, this problem is deceptively easy. Okay, so first let's just dissect the equation there. Notice this is, they have the derivatives down to y. So this is some linear equation. And then I know that this and this and this and that, there should be an x on the a inside n minus 1. Um, I know that I'm going to multiply every orange and purple, every derivative with the a functions. And then I know that since it's linear and it's written this way with these x's like that, I know there's no y's in it. All right. So let's take our derivatives. I'm going to need up to the nth derivative. Okay, so, and you're like, how do we actually get there? Well, in this case, it does make sense. Okay, y to the zero, y equals 0. Y prime then would be 0. Y double prime would be 0. And then that means if I keep going, y to the nth power is going to be 0. All of them are 0, right? The derivatives. So if I were to write this out, and I'm verifying, so I got to show this. I know it seems silly. I'm going to put a 0 there. A minus 1, there should be an x here. That's what I was saying a second ago. Times 0 here. Plus dot dot dot. Plus a sub 1 x times the 0 there. Plus a sub 0 of x times the 0 there. Well, that's my left-hand side. That's what we're working on, right? Left-hand side. And that's going to create a 0, right? Everything 0 plus 0. I guess we could write that out. 0 plus 0 plus dot 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 plus 0 plus 0 0. If you were to just write 0, I'd be satisfied there with you showing that line above it there. All right. So some of these theory questions, if you see them, just do your best to dissect what the equation is. Most of the time, like this problem, it's extremely straightforward. I'm not going to ever throw some type of theory problem that's going to take 2 pages of explanation. Most time, the theory explanations require more thought than work. All right, there's our first section.